Welcome to Safety Spectrum, your environmental health and safety connection. This program is a presentation of the Michigan Safety Conference. For almost a century, the annual conference has provided credible educational opportunities and valuable support to the safety and health practitioner by offering 120 instructional programs along with exhibits highlighting the latest in safety equipment, instrumentation, and demonstrations. To learn more about the conference, please find us at safetyconference.org. Welcome to Safety Spectrum. I'm your host, Sheila Ide. Our program is Lithium-ion Battery Update, Friend or Foe. This program today is sponsored by Liberty Footwear, a family-owned shoe factory in Grand Rapids, Michigan, founded in 2016 to respond to demand for boots and shoes built in America. They focus on work, outdoor, and casual boots made to fit each foot, customized for various environments with a variety of outsoles and other features. They also offer a wide variety of unisex sizes and widths, and their factory outlet store is open Monday to Saturday. So, what is going on in the lithium-ion battery world? What has changed? What new strategies are there for emergency response personnel? Have new concerns emerged? Our speaker will address some of these questions in our discussion today. Our guest, Mike Snyder, serves as Vice President, Operational Risk Management for DEKRA Process Safety, advisors in the chemical process safety testing and consulting services. Mike was previously the Global Director of Safety and Loss Prevention for Dow Corning Corporation, responsible for leading the company's occupational and process safety programs. He is also a proud retired fire chief and fire marshal. I know that's important. We have a lot of fire folks on the safety conference. Mike currently serves on the Center for Chemical Process Safety Governance Board and is a member of the NFPA Board of Directors. He currently serves as a technical member on several NFPA code committees. Mike holds a bachelor's degree in chemical engineering from Cornell and a master's in occupational safety and health. He is also a registered professional engineer in Michigan, as well as a certified safety professional and certified fire protection specialist. So thank you for joining me today on Safety Spectrum, Mike.
Well, thanks for having me join your audience today. I'm looking forward to our discussion.
Well, let's get right down to basics. How does a lithium-ion battery work? Educate me.
Okay, so central to the conversation, a lithium-ion battery is a battery, right? And so specific to this technology, there are four basic components that we want to just talk about from architecture. And I promise we're not going to go too deep or into the weeds here, but you basically have an anode, which is the negative terminal, a cathode, which is the positive terminal, an electrolyte, which is we'll talk a bit about ions, and a separator. And so each of these components works together to allow the stored energy within a battery to be able to discharge. We take that energy as electricity. Those electricity is really from electrons. And what happens is we flow from the anode to the cathode through the electrolyte, and that's essentially what powers a circuit or any type of load that we're going to need. Now, as we've talked before, when we first discussed the challenges with lithium-ion batteries, back in 2023, lithium-ion batteries are very important to the alternative energy economy, number one, because they have a tremendous amount of energy density. So in other words, they can pack a lot of energy in a very small footprint. The second part is that they are what are called secondary cells, so they're able to be recharged. And most lithium-ion batteries can be recharged about 1,000 times before they start to really lose their effectiveness and efficiency. So, again, a life cycle of a lithium-ion battery, if you charge it every day, would probably be about 7 or 8 years before you're going to have to think about next life or recycling. And so, ultimately, the unique nature of the lithium-ion battery deals predominantly with the cathode. That is where a lot of the reactivity and energy issues arise. There are a number of different technologies and chemistries that are used at that cathode. We'll talk a little bit more about those. The electrolyte, which allows the ions to move from the anode to the cathode, those today generally with lithium-ion batteries are an organic carbonate, which is a flammable liquid or low flash point combustible liquid. So if we have kind of an abnormal situation, we have a flammable liquid hazard that we have to manage. And then we have the separator, which if you kind of think about a lithium-ion battery, a typical one, kind of like a cylindrical cell, like a AA battery, that separates the anode and cathode so that the separator is a piece of plastic that allows the ions to move through, but also keeps the anode and the cathode separated so you don't have a short circuit. Um, Two other quick things that I'll mention, and as we'll talk in more detail here. Despite the name lithium being in lithium ion, there's no free lithium metal. And so when we have a fire or other situation here, it is not a combustible metal fire. And so those strategies, sometimes people think, oh, I need a Class D fire extinguisher. That is not accurate. We'll talk about emergency response procedures. And another aspect of these batteries as we try to characterize their hazard and risk is what's known as state of charge. How much of the battery's capacity has energy in it? And when you charge it fully up, that would be about 100%. And then as you use it, it goes down. And what we find is that the battery's hazard significantly changes at about 30% state of charge. So oftentimes, well, number one, regulatorily, if you ship a lithium-ion battery, it needs to be shipped below 30% state of charge. It's at a very different state of hazard. And so, again, if we're storing a battery in a warehouse, if we can store it at 30% or less state of charge, the nature of the risk that we have to manage is very different. Now, obviously, when you have an EV or a battery energy storage or a consumer product, you're typically going to operate it at higher levels of state of charge, and that's where some of the unique hazards, fire, thermal runaway, and explosions can occur.
Makes me wonder, is this a good idea? Were lithium-ion batteries a good idea?
So I think the reality that we're facing here, both in consumer products as well as in, e-mobility. So this whole cycle from, scooter boards all the way up to EVs, as well as battery energy storage. We need some vehicle, some method by which we can store a lot of energy in moderately compressed footprints. What I would say is, again, we have to think about the fact that under normal circumstances, lithium-ion batteries perform exceptionally well. And what we're looking at is a very, very small percentage of time where abnormal or abusive situations arise that prevent or present the unintended consequences that we're talking about. Lithium-ion batteries have been around commercially since the 1990s. Obviously, in the last 5 or 6 years, they have become relied upon much more tremendously than they ever have before for all these reasons that we're talking about. So I always talk about this through the lens of an environmental health safety or emergency response professional. We have a risk here, no question at all. And there are scenarios and situations where significant undesired events, consequences can occur. But if we identify the hazard, we identify the things that can create that hazard, and we put proper safeguards in place, we can manage this hazard. Again, it's not that it doesn't have challenges, but to your point of in a perfect world, we try to have something that would not have any of these consequences. We'd make it
Okay.
completely inherently safe. But today, the reality is both in consumer, transportation, and battery energy storage, this is one of the best technologies that's available, but we have to be very aware of the unique hazards it presents.
Well, it kind of leads into my next thought is there is a certain emphasis or de-emphasis on renewable sources right now. Do you think that's having an impact on the development of these kind of things or the use of these kind of things, maybe?
So I think
With support.
there's a change in the mix of what's going on. So in the last couple of years, right, government policy is in some cases de-emphasizing, particularly like EV mandates in other areas there. But clearly, if you go to a home supply or hardware store today, you probably see 3 times the number of lithium-ion battery powered tools, lawn equipment, and other areas. So we're picking up in that area. We'll talk I think a little bit later about the fact there's a lot of new hazards, right? That
Mhm.
that market is presenting, and we have to be aware of, and just again some good behaviors and good practices that have to come here. But let's also face the fact that the renewable energy mandates, and now I'm talking more about grid distribution, where we have to balance generation and utilization, that's only going to continue. It might slow a little bit, but battery energy storage systems are going to really start to become, I think, quite prolific throughout the network, and we're going to see a lot more of those. Now, the good news is we have better engineering standards and recognized engineering practices that help guide safe designs and installations in this area. And so many of the issues that we've experienced in 2018 to early 2020s, many of those are being addressed in modern design. So yes, I think the dynamics have changed a little bit, but lithium-ion batteries are not going away.
Okay, then let's talk about the real bugaboo. Could you explain thermal runaway and have the causes of it changed?
Right. So thermal runaway occurs, and the way that I try to explain this, and a purist would argue with me, but it works very, very well, is when you basically get a short circuit in the battery, right? And there's three basic abuse mechanisms that can occur to cause that that short circuit. You can have a mechanical abuse piece, and that's like something penetrates the battery, and we find ways to connect the anode and the cathode. We discharge a lot of energy, we generate a lot of heat, and in that case, the electrolyte starts to boil, and you start to either vent through design vents or through the failure of the pressure containment of the cell, and you end up with a jet fire, right? And that then will, if there are adjacent cells, you'll propagate that from cell to cell. Those same abuse mechanisms can occur with electrical abuse. So in other words, if you significantly overcharge or over discharge or do in a way where it's supposed to, the battery management system or charging system is supposed to stop and it doesn't stop and you overcharge the battery, you'll get the same type of situation where you'll cause a damage, which starts kind of this electrical short circuitry. And then the last one is thermal abuse. And there are lots of ways that thermal abuse can occur, but the most common way is if something that's not directly related to the battery starts on fire, creates a heat exposure to the battery, you can start that process. And once that process starts, until all of the energy is displaced or discharged from the battery, that thermal runaway, that reaction, that fire and release will occur until you're done, until the energy is removed. And that's why the major challenge we have with both battery energy storage, with consumer goods, and with EVs is if you don't get the discharge and there's still that short circuit present, you'll have a second fire, a third fire. It just basically kind of reignites and causes some of the consternation that's here. Now, one other comment that I'll make, because it's important from our environmental health and safety perspective, while fire and explosion from the gases that are evolved when this thermal runaway occurs, right? We're evolving electrolyte, so that's a flammable liquid. We get combustion, we get breakdown products, which include hydrogen, which can fill up a room, become an explosion hazard. Carbon monoxide, which has some toxicity, but also is a flammable gas. But also in the electrolyte, we add during the manufacturing process a lithium fluoride salt, and that's to help the ions move from the anode to the cathode. And in that particular circumstance, actually the ions move the other way from the electrons from the cathode back to the anode. But when that is exposed to fire, that lithium fluoride salt will start to break down and it will evolve hydrogen fluoride or hydrofluoric acid. And so one of the other issues in these rare events of thermal runaway is we also emit a toxic gas called hydrogen fluoride or hydrofluoric acid.
Ouch. Not good. So then you talked a little bit about it, but what are the new approaches coming out to detect or prevent or contain these thermal episodes?
So, number one, there's a lot of technology that has evolved. Let's look at the basic architecture of how lithium-ion batteries are put together, because I think that'll be important to how do we control the overall hazard, fire, and size and duration of an event. When we commercially use lithium-ion batteries, it's generally not a single cell. Cells are put together in units that are called modules, and modules are then put together and become packs. And if you have an electric vehicle, you literally have thousands of cells that are put together. And a typical lithium-ion cell, depending on its chemistry, will generate about 3.5 to 4 volts of DC voltage. And as you look at that and you need more voltage or you need more current, you put these batteries together, these cells, in series and parallel, and that's how you form the modules in the pack. So all events start at the cellular level. There will be a cell that gets some abuse mechanism. It can have a problem where, say, the separator is failing or has been damaged because the unit has been dropped. That cell goes into thermal runaway. It generates heat and fire. It exposes neighboring cells, and that's a cascading set of effects. So there's a lot of research going on in trying to make these units more inherently robust. So in other words, if you kind of think about this, insulation technology between cell to cell, but you have to do it in a way that you don't add a lot of weight to the vehicle, right? There are practical implications that are here. We are also getting better about what is being used for the electrolyte. First generation, second generation electrolytes were flammable and low flash point combustible liquids. There are more inherently safe, that is, higher flash point, less flammable electrolytes being developed. And on the horizon, you'll hear people talk about solid state lithium ion batteries. And what they mean is that the electrolyte is configured instead of a liquid or gel as more of a solid phase, so that even if you start to have a spill or a release, it's not going to be kind of then a release of a flammable liquid. It's more of more of an inherently safer solid material that is going there. I would also just say that our engineering and NFPA and other related standards, we have obviously through incident experience and also through a variety of testing, have gotten newer best practices. And so there's really, since the last time we talked, there have been a lot of new updates to the standards that occurred in late 2023 and 2024 that give us better ways to control and look at how these hazards are managed. Lastly, um, our basic toolkit that we have in fire and emergency response, thermal imaging cameras and carbon monoxide detectors, are becoming more commonly utilized at times to identify if there is a thermal runaway occurring. But again, as we talked before, I want to be very, very direct here. Once you start to see the heat and you start to see the evolution of gases, you have minutes,
Hmm.
sometimes maybe a minute or two before you're going to start to see the first signs of thermal runaway. So these are more of diagnostic tools than preventative tools in that area. I go back, again, our major control mechanism once thermal runaway begins is the use of copious amounts of water. And obviously, the smaller the device, the easier it is to kind of move that device in like a gloved hand and immerse it, say, in a barrel or bucket of water. Obviously, in EVs, it's more about how you apply that. And with battery energy storage, which are kind of these large overseas container-sized modules, it's about making sure that you have adequate sprinkler protection, isolation, and then obviously we monitor and detect the fact that we may have smoke or off gases that occur.
Detecting it early sounds like the key. Though I have to say it when you mentioned the cells being separated, I had a picture of the Titanic.
Oh,
The
yeah,
idea they had separate chambers, and then that didn't it saved
correct.
anyway.
Yeah, so again, there's a lot of there's a lot of new research and development going on, but the reality is that's for kind of next generation battery technology. And so
Gotcha.
while we'll see continual improvement, some of these, I'm going to call them significant changes, like solid state lithium ion
Yeah.
batteries, is probably, and I use the word a generation, 5 to 10 years out before we're going to see the benefits that are going on there. I'll make one other part is, or one other reference here is when we talked 2 years ago, there was a move afoot to use lithium iron phosphate or LFP as at that time it was kind of a new cathode material. And I said, right, this reactivity and thermal runaway propensity is very, very much based on the chemistry that is used in the cathode. And there has been a lot, or there have been a lot of adoptions of that where appropriate. And that is a safer, inherently safer technology. Just as a reminder, why doesn't everybody rush to use that technology? The issue is it doesn't provide the amount of energy density and other attributes of the operating cell. You need kind of a larger, heavier battery to give you the same amount of energy. And so on things like a car, where weight is extremely important, it's not what I would call a no-brainer decision. You're going to have to kind of balance that with a lot of different areas. But I would say the adoption of lithium iron phosphate cathodes has been much more prevalent than where we were 2 years ago.
So it's like we're learning as we go, which is pretty much emerging technology. That's the way it works. And sometimes you think it's, oh, why did we do it that way 5 years ago? So I totally
Correct.
get it. So let's go a different route. How have emergency response strategies evolved for lithium ion battery fires?
So, first of all, there is a lot of information that's being shared uh, through, and I call them the firefighting professional associations, and actually through a lot of the manufacturing organizations. And, for example, I call out Tesla. They have both in their power walls, which kind of their battery energy storage system products, as well as their cars. They have provided a lot of outreach to fire service and other emergency response agencies. So, this starts with the fact that I would say virtually every fire department today has at least had some concept and discussion about lithium-ion batteries. Now, again, the depth and breadth of that knowledge is still variable. We have a lot of other authoritative resources. I'll call out very specifically Underwriters Laboratory has the Fire Safety Research Institute, FSRI, who has a website that publishes for free a lot of data both on procedures as well as emerging research that they're doing. So for example, right now, the FSRI is doing a lot of what we would call fundamental burning tests that are looking at how does an EV, an electric vehicle, fire progress, and what kinds of interventions give you the most effectiveness. By the way, it's interesting for all the history we have with internal combustion engines, there wasn't a lot of data, research data about how does an ICE vehicle burn. And so part of what FSRI is doing is they're baselining normal, internal combustion engines, and we're finding all kinds of interesting gas generation and other attributes that on reflection start to make sense, but it's kind of not like internal combustion engines are at this very, very low risk and EVs are at this high risk. We have different risks that have to be managed. I do want to be, I use the word authoritative, and I want to be very explicit about that. In that, there's every day you can go on the internet, you can go on YouTube, and you see all kinds of information and prognosticators about the new magic technology for controlling a lithium-ion battery fire. And I just caution folks that while we want to embrace advancements in technology, absolutely, it needs to be peer reviewed, it needs to be authoritative for you to really kind of put the safety of your crew, your employees, your own life in your hands, I think, before you would embrace that. So much like you would not want to make an investment of money unless you had an authoritative source to go after, just please be very careful that you don't necessarily get caught up with the meme of the day or the theory of the day. Make sure you're going back to authoritative resources. And obviously, things NFPA, FSRI that I talked about, the automotive manufacturers are all very solid sources of information. The YouTube video of the day, maybe I'd be a little cautious about, and just make sure that there's research and peer-reviewed data that you can review before you would maybe make a decision about how you would change your emergency response.
And I would also suggest the Professional Firefighters Association. They're going to be the ones that are on the front lines of experience and the peer-reviewed information that's out there. They're the ones using it.
Correct. Now,
So,
one other thing that I'll mention, and this is it's a firefighting strategy, but it's really more of a firefighting risk and exposure. As I mentioned, when thermal runaway occurs, you end up evolving the electrolyte that's vaporized, but hydrogen and carbon monoxide in addition to hydrofluoric acid. It doesn't take very much hydrogen, particularly in an enclosed area, to have that entire enclosed area be essentially at explosive concentrations. And one area that we continue to learn a lot more about is when thermal runaway occurs in confined areas. So inside a garage, inside a subterranean, so underground parking garage. The accumulation of hydrogen doesn't take very long. And obviously, if you have a fire, you have an ignition source, but you go into a garage, there's lots, in Michigan in particular, we have refrigerators, we have water heaters, we have furnaces that oftentimes are in there. So you have an ignition source. So if something goes into thermal runaway in an enclosed area like a garage, we have to be extremely, extremely sensitive to the fact that there could be a room explosion hazard. So what does that mean? In strategy and tactics, when we're approaching a garage fire, if an explosion occurs in a garage, one of the weak links of the garage, right? Because we don't design explosion venting into most modern garages, but would be the garage door. So if you're approaching a garage fire, right, and not knowing necessarily the source of that fire, you don't want to be approaching right directly in front of the garage door, because if something does explode, the garage door comes out after you. And clearly there have been some well captured videos, typically from first responder body cams, that have shown that you just approach from an oblique angle, right? So that if it does explode as you're going from there, you're not necessarily in the line of fire. Unfortunately, back in when I did the presentation at Michigan Safety Conference earlier this year, we did review a subterranean parking garage situation in Spain, where again, at the early phases of a car fire underground, that was involving a thermal runaway. It was a known EV situation. Fire department went in to extinguish the fire, again in an enclosed area, and basically a compartment explosion occurred, and it killed two firefighters. We just have to, again, it's about, this isn't critical of the strategy and the response that's there, but we have to really make sure we add that to how we're identifying the on-scene hazards and making sure that we're taking them into account before we put somebody in harm's way.
Well, to follow up with that, has there been any unexpected safety concerns that have emerged, particularly for responders and bystanders in addition to that?
So, I mean, there's a lot of discussion about EVs in parking garages just because they can burn for a long period of time. And, how do you put charging stations in there? We're getting better, right, about really trying to diversify the risk that is there. But, obviously a parking garage that is exposed outdoors, you're generally not going to get the accumulation that can lead to an explosion. Then it's really more about the fire and the hydrofluoric acid. It's just, again, if you are parking these in enclosed areas, the explosion hazard is a new one that we have to think about. Obviously, when you potentially expose citizens or firefighters to hydrofluoric acid, number one, we have to make sure we have good respiratory protection, right? And this is to our basic blocking and tackling: full structural firefighter turnout gear, full respiratory protection. HF, if you exposed it both topically as well as inhalation, there's lots of really bad things, right, as far as the impact that can happen there. And we need to be sensitive to the fact that after we have that exposure, we're doing extremely good hygiene with doing our gear decontamination and cleaning. Again, both of these are kind of, I'm going to call them leading thoughts. It's modern thoughts in how we provide good safety and health protection for our responders.
So, what would you say critical practices should be implemented in the workplace and in homes? I know I'm going to park my EV outside the garage, number one.
Yeah, so um, there's a couple of things, right? And there's kind of, I'm going to call it the personal actions and behaviors. I'll come back to those in a second, and then kind of our workplace areas. So one of the emerging areas in workplace safety is all of these smaller units that are using lithium-ion batteries. So whether that's drills or other types of maintenance equipment. And, part of that is, if you really think about abuse mechanisms, a drill in a workplace probably has a much larger chance of being dropped or abused or overheated, or than say you have an EV tug or something like that. They both can be exposed, but somebody dropping a drill from multiple feet is a likely scenario. And we just need to start to get people and employees to think about, that's an abuse mechanism. We need to isolate that area, that battery, and either put it in a defined fire resistive cabinet or get it in an isolation area outside the building so that it can either be further analyzed, repaired, or disposed of. Um, we're just seeing, and again, I'm not trying to say this is like we're seeing thousands of these a day, but we're seeing a lot more fires that are arising from simple maintenance and mechanical tools, as well as obviously in apartment complexes, we're also seeing a lot more with like scooters and hoverboards. The big issue there is from a safety standpoint, we need to make sure that whatever we are charging with is matching what was the manufacturer's design for the battery that you're charging, right? And so once you start, the battery and the charger, and as you get further up the food chain, you would call it a battery management system, has safety features that manage overcharge, over discharge, or other anomalies that it will stop the charging if it detects a fault. If you go onto the secondary market and find, kind of a battery charger that is made from some non-OEM source, it's likely going to charge your battery, but it may be compromising one or more of those safety systems. And so despite my wife and I always have these debates about the fact that, oh, you can get it cheaper on Amazon. With lithium-ion batteries, the replacement battery and the charger need to match, and they need to match what the original manufacturer had. And I will tell you, they're going to be more expensive. But in this particular circumstance, the risk factors by using these kind of off the specification area are significant, and that's where a lot of these hoverboards or other tool problems occur, because it's like a second generation charger. So that's true in the workplace. It's also true on the home front. That's kind of a very active preventive measure that you have. I would also say, and again, I know people look at me at times like I'm a little bit crazy here, but charging batteries while unattended, in the rare event that it does have an anomaly or go into thermal runaway, if you're able to respond quickly, you can likely contain, especially for consumer electronics, that fire or problem very localized and take care of it very quickly. If it festers for a period of time, fires will grow, the thermal runaway will propagate, and you end up with a much more significant damage. And so, lithium-ion batteries, say for tool motors or for other types of hand tools, if that starts to propagate, you can end up having a fire that will destroy a home. Where if you catch it very early, it's starting to smoke and other types of things, you can remove it remotely or even dump it in a bucket of water and likely limit the propagation of that. And I
So don't
always like
start charging and then go to bed.
even with personal computers. Now, again, there comes a point here that I'm not trying to be like overly cautious, but I tend to disconnect my battery overnight. Disconnect the charging mechanism to my laptop overnight, just so that if I'm charging it, it's kind of in an area that I can see if there's a problem, or I'm conscious to the environment. A couple of quick things that I'll just kind of mention that are analogs here. This is the way and the behavior that we're really trying to enable in air traffic travel, right? In a standpoint that, it's still the honor system, but you're asked, are there any lithium-ion batteries in your suitcase, right? That's going to be checked and put in the cargo hold of a plane. And the whole issue there is, if it goes into thermal runaway in the cargo hold, there will be delayed detection. And then once you get a fire in the cargo hold of an aircraft, significant consequences are going to occur. And that's why you bring your laptop, your cell phone, and other things into the cargo hold. I will also say that there are new technologies, right? As we were kind of saying, what are some new and innovative approaches here? For many, many years, as long as I've been involved in the environmental health and safety community, we recognize that with flammable liquids, that flammable liquid storage cabinets are a good safety feature when you're not pouring, dispensing, or using, say, flammable liquids in bottles or small cans in your lab or in your maintenance area. You put them in there because then they're protected from a fire in the building. And if there's a problem there, it can separate and also protect the building from a problem that's there. It's basically like a fire separation cabinet. Today, and now there are UL standards that have been designed for a similar technology. So basically a lithium ion battery storage cabinet and a lithium ion battery charging cabinet, with the same basic philosophy that it isolates the surrounding from the lithium ion battery and vice versa. And so if we are going to be doing charging, or if you're going to be doing charging in the work environment unattended, that would be kind of a natural thing. Again, taking the knowledge that we have about flammable liquid cabinets and transferring them into lithium-ion battery technology, something that has been new to the market here in the last 12 to 14 months.
So are there some new research developments that are on the horizon that are going to be helpful?
So again, I mentioned the Fire Safety Research Institute, which is a branch focused on fire safety, firefighter safety, and emergency response that Underwriters Laboratory supports. They have a lot of important data that they're sharing through their website. It is also important, and FSRI, in addition to the National Fire Protection Association, independently have discovered that when professionals have been using lithium ion fire blankets, that they have been trapping some of the hydrogen that we've talked about under the blanket. And then if somebody gets up to the blanket and moves the blanket, right, there's a fire, they've seen some localized explosions that
Huh.
have created scenarios that could harm firefighters, right, or people who are deploying those. So just if you're not familiar with lithium-ion battery fire blankets, um, oftentimes, like if you have multiple electric vehicles parked next to each other, and if one catches fire, you're trying to really protect the exposures. I mean, the car that's on fire in thermal runaway, that car is going to likely be damaged beyond any kind of repair. But there have been, for lack of a better word, specialized design fire blankets that can be rapidly deployed over the burning car. Now, again, they don't stop the thermal runaway, but they stop all the other components that are burning. So it slows down the heat release rate. And in general, they've been very effective. I would say in Europe, there's a lot of use of that in the emergency response community. Now, if you put them on, sometimes you come back and you try to readjust them, or you're kind of now doing kind of a verification or checking of what's going on. And in both of these testing organizations, FSRI and the Fire Protection Research Foundation, as part of NFPA, they had events where moving that blanket, they had these localized explosions, and they have both issued safety warnings to the fire protection emergency response community about the fact that you need to contemplate that in your overall risk evaluation. Some people have taken that to the point of saying we aren't going to deploy the lithium ion fire blankets. I understand that particular approach. However, I do believe, this is again like anything that we're dealing with in environmental health and safety. Look at the scenario, figure out the best deployment, and how can you control the risk and hazard. It's a tool in our toolbox, but we're learning a little bit more that it's not like the magic tool. We do need to understand that there are some risks that have to be managed.
Yeah, and I hate to do this to you because I always enjoy our talks, but have you got any final thoughts that you want to wrap up or leave with our audience to contemplate? I think you've given us a lot to contemplate.
Yeah. So, the last time we talked, I tried to put the hazard of lithium-ion batteries in a risk-balanced view. We clearly still have thermal runaway, fire explosion, and hydrofluoric acid exposure e- events that we have to factor into the way that we manage this hazard. What I would say is that our recognized and generally accepted good engineering practices, also known as RIGAGAP, so like NFPA 855, some of the in 2024, the International Building and Fire Code, as well as now many of our insurance companies have gotten very much updated information. And I will just make a quick shout out. We've talked about FSRI, we've talked about NFPA. FM Global, or now FM, has published a data sheet. It's data sheet 7-112, which is a great resource for the hazards and engineering controls of lithium-ion battery fire hazards, including storage configuration, sprinkler protection, and spacing. It's a very, very good guide, particularly for the workplace in this area. So we are getting better about making sure that new installations and new operations are embedding this knowledge. We do have to be aware, however, that there are lots of things that have been essentially installed with weaker or sometimes non-existent standards. And so, again, we do need to be aware that there will be some events that go back in time from older designs. We know we're going to have to catch up on those. But again, I need the community, the environmental health and safety community that's listening to this podcast, be skeptical, be inquisitive. If a bad event has occurred in public, what was the design basis? What was it based on? Was it new Rigagap, old Rigagap? And again, as we get these learning experiences, as we get better testing knowledge, we're moving forward. So again, keep your mind open to the fact that we have to identify the hazard. We need to understand the safeguards and controls that are there, and then make sure that we have effective emergency plans and we continue to stay at the top of our game as far as gaining knowledge here. And this risk can be managed.
Okay, that's what I want to hear. Well, our mission with the Michigan Safety Conference is to enhance workplace health and safety by sharing EHS best practices, provide education, and create a community of experts to eliminate workplace injuries and fatalities. Though there are challenges, lithium-ion battery usage and the need for reflection on new safety practices will continue to evolve. Constant education and monitoring is essential, and I might mention again that FM Global Data Sheet 7-112 that Mike mentioned. So I'd like to thank Mike Snyder of DEKRA Process Safety. If you have comments or you'd like links to some of Mike's articles on the topic, he can be reached at mike.snyder@dekra.com. And I'd also like to thank our sponsor again this month, Liberty Footwear from Grand Rapids, Michigan. They can be reached at libertyfootwear.com. If you have any questions about this podcast, the Michigan Safety Conference, or you'd like to be a guest or sponsor one of our podcasts, info can be found on our website at michsafetyconference.org. Thank you for listening to Safety Spectrum. This is Sheila Ide.